So, in dealing with a continuous distribution, we always have a random variable x, that has a probability density function of the form f of x is equal to a constant k if a less than or equal to x less than or equal to b and 0 otherwise. So this is the probability density function of a uniform distribution, or I say it is a constant, or the probability is constant for all x between a and b. So I say that this is a constant, but I don't know what it is. So to check what it is, what this k is, I'm going to plot this AB and I say this is some k. So this is my PDF. This is how the PDF will be, and because of this rectangular shape is what this name of rectangular distribution came for this uniform distribution in continuous case. So we are going to find what is this k. So to find what is this k, we know if f of x is a PDF, then integral over the full range f of x dx will yield us 1. So what I am going to do is I am going to integrate this. So integrate x f of x dx is equal to integral a to b. F of x is a constant k dx. So I know integrating a PDF over its full range will yield us 1. So this is equal to 1. This implies the integral of k dx is, k is a constant, so it will be kx from a to b equal to 1. That implies k into b minus a is equal to 1 and k must be 1 by b minus a. So this line is 1 by b minus a and it is 0 otherwise. So this k is equal to 1 by b minus a. Therefore, a random variable x has a probability density function of the form f of x is equal to 1 by b minus a for a less than or equal to x less than or equal to b. Then we say that random variable x follows a uniform distribution in continuous case or a rectangular distribution. Therefore, we can formally write the PDF as f of x is equal to 1 by b minus a for a less than or equal to x less than or equal to b and 0 otherwise. So this is the PDF of a uniform distribution. Distribution function of uniform distribution. To say about distribution function of uniform distribution, we know it is denoted by capital F of x. The uniform distribution is denoted by capital F of x, which is equal to probability of x less than or equal to small x. Isn't it? Yes. This is equal to integral minus infinity to x f of x dx. So here the range of x is from a to b. So we are going to integrate the uniform distribution, the PDF of uniform distribution from a to x f of x dx in order to get the distribution function. This is equal to integral a to x 1 by b minus a dx. We have already replaced this k by 1 by b minus a. So now the PDF is 1 by b minus a. So this is equal to x by b minus a from a to x, which is equal to x minus a divided by b minus a for a less than or equal to x. Less than or equal to b. Now we are going to discuss the mean of the uniform distribution. So how to find the mean of the uniform distribution? Mean is denoted by expectation of x, which is equal to integral over x over the range of x f of x dx. X into f of x dx. So if it was in the discrete case, we will be finding the summation over x f of x dx. So since this is a continuous uniform distribution, this is our formula. So this is equal to integral a to b x f of x dx, which is equal to integral a to b x into 1 by b minus a dx, and that will yield us 1 by b minus a into x square by 2 from a to b. Isn't it? Yes. So this is b square minus a square divided by b minus a into 2. So which is equal to b plus a divided by 2. So expectation of x is equal to b plus a by 2. Okay. Now we are going to find variance of the uniform distribution. To find the variance of the uniform distribution, we have two formulas. So variance of x is denoted by v of x, and we can find out either by using the first formula or the second formula. So the first one is expectation of x square minus expectation of x the whole square, and also it is equal to expectation of x minus expectation of x the whole square. So we are going to use this formula to find the variance of x. So we have already found expectation of x the whole square, and what we don't know is the expectation of x square. So we are going to check what is expectation of x square. So just as we have found the expectation of x, the mean, we can find expectation of x square. This is equal to integral over the range of x square f of x dx, which is equal to integral from a to b x square into 1 by b minus a dx. So this is equal to 1 by b minus a into x cubed by 3 into from a to b. So this will yield me b cube minus a cube divided by 3 into b minus a. So we know the expansion of b cube by a cube, isn't it? So that is b minus a into b square plus ab plus a square. This is the expansion of b cube minus a cube divided by 3 into b minus a. So this b minus a and b minus a gets cancelled, and what is left is b square plus ab plus a square divided by 3. So we have got expectation of x square, that is equal to b square plus ab plus a square divided by 3. Now what is left is we have to find the variance of x from this formula. So variance of x is equal to expectation of x square minus expectation of x the whole square, which is equal to b square plus ab plus a square divided by 3 minus expectation of x was a plus b by 2, and we're going to square that. So this is equal to b square plus ab plus a square divided by 3 minus a square plus b square plus 2ab divided by 4. So here what we are going to do is we are going to multiply it, and we are going to simplify that. So 4b square plus 4ab plus 4a square minus 3a square minus 3b square minus 6ab divided by 12. So which is equal to b square plus a square minus 2ab divided by 12, and that is b minus a the whole square divided by 12. So this is the variance of x. V of x is equal to b minus a whole square divided by 12. Okay. Now what we are going to do is moment generating function. So moment generating function is denoted by mxt, which is also called mgf. So mxt, which is equal to expectation of e raised to tx. Expectation of e raised to tx can be written as integral over x e raised to tx into f of x dx, which is equal to integral from a to b e raised to tx into f of x dx. I know my f of x is a uniform distribution, so it is 1 by b minus a, which is equal to integral a to b e raised to tx divided by b minus a dx. So this is equal to, I'm going to write it here, this is equal to 1 by b minus a from integral a to b e raised to tx dx, and that is 1 by b minus a from e raised to tx divided by t from a to b. So this is e raised to tb minus e raised to ta divided by t into b minus a. So this is the MGF of uniform distribution, e raised to tb minus e raised to ta divided by t into b minus a. I hope this video was useful. Thank you.